We're now going over a chair conformation on textbook chapter 4. It's page 72, question 31D. Okay, it's asking for the most stable conformation. There are two things that we should know first, like which is a bulkier group. Which is a bulkier? Okay, okay. So it's a. So later I'll just use green for the huge group. Okay, large. Am I good? It works for all the small, okay? It works for all the large, and so you just need to compare which one is larger or which one is smaller. Are we good? So that way it's not only D, okay? I'll use a blue for small. Okay, now it's become a question of what do I have? Okay, what do I have? I have large group in axial. Are people good with this is axial? Okay, so, okay, all those are axial, okay? All those are axial. Okay, I have small ones, yeah. Okay, those are axial. Okay, these are axial. I know it's axial. Okay, you want the smaller group to be equatorial. How do we know equatorial? I'm not writing it on the chair, so it's not going to mess up my chair conformation. Equatorial always parallel to one of your bond. You can go find which one. Okay, so this one, they're equatorial on this side. Okay, here, it's parallel here. Okay, I don't want to write on it, so it's not going to. Okay, and here the equatorial should be written like this. Okay, so that's here. This one, the equatorial should be written like here, this. Okay, so equatorial is just like axial is all vertical. Equatorial is roughly parallel to the plane. Are we good? Okay, now we're going to do the ring flip. Okay, ring flip. Oh, that's you will need ring flip for your whatever. Okay, quiz exam whatever. Okay, do ring flip on your side. I'll do it on the board. Okay, it should take 3 seconds for you to draw a ring. Okay, if you cannot do that, you're too slow. Okay. I'm waiting for everyone to finish draw their ring.
You can ignore me. I'll be happy.
Oh, okay. All right. So it's fine. It's fine. Take your time on drawing your ring. I'll start to put the labels on. Okay. Yeah. Take your time. You just learned this. Yeah. But since we're here, it's like a lot of the time. I know the first midterm is not too long. If you actually take a look of Dr. Nassiri's midterm, all her midterm is very short, but it's kind of like I would think the workload on the second midterm is more because you want look at how many reactions that she has. It's actually the reactions that will take more thinking on it. That's what I meant by, okay, it takes 3 seconds for you to draw a ring because you want leave some time for you to do the mental things. Especially the model ones I showed, okay, there are a lot of decisions you want to make, which reaction I will be using. Some of you already are working on SN1, SN2. So it's before you actually write the structure. I said I don't test the vocabulary, but where is the hard part? Is the mental exercise. Which mechanism does this reaction go? You have a decision you need to make. After I know this is the mechanism, are they forming stereocenters? Do I need to write a pair of enantiomers or diastereomers? So it's a lot of the mental thing. Okay, I get. Okay, people finish writing the ring, right? Okay, now we do this. Okay, small group in equatorial, right? Okay, small group in equatorial. I'll do it with this brown. Okay, it's on. Okay, I'll label the carbon one. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Okay, number 1 here. Okay, it's in equatorial, right? So I'll do like this. Oh, sorry. It's not.
It should be on the right one.
Uh,
Other one, right?
Yeah. So I labeled the carbon wrong, sorry. Okay. So this is my carbon number 6 now, okay? 6, 1, 2, 3, 4, 5. Okay, my number 1, you want this, so it's pointing up. It should still be pointing up, okay? No, that's, the previous one was correct. Yeah, I'm so sorry, okay. Because, okay, this is what I was looking for. Your small one was on equatorial, are we good? Because the axial one should be this one, right? So when you do the ring flip, what was said, all your equatorial should become axial. So you can find it will be correct on this side, okay? So now if you want to get a axial one, so it's actually pointing up like this. So this is number 1, okay? This is 6, okay, number 2. We'll just need all of them. We don't need all of them. So number 1. So now it's my small group, okay? It's pointing up. It's the small, okay? Okay. My number 5, that's the large group, okay? Large group, okay. Okay, the large group, number 5, now pointing down. Are we good? So when you do ring flip, it's really, I'm looking at your previous axial should become equatorial. Your previous equatorial should become axial. That's, otherwise it's another ring. It's not flipping. It's just look from a different perspective. Because if you do one more ring flip, it will go back to that. But you just do one more. Are we cool with that? Yes?
So when we're drawing these, is there a way that we can like specifically draw them? Because that kind of looks axial to me. Is there a way that we can?
Yeah. So if you want this to be perfectly, this one is the one that you should follow, the bond. Okay, this bond, you do exactly parallel. Okay. Are we good with that? Okay, the small. Okay, how to differentiate the axial group? The axial group on that one, okay, is this hydrogen. This is the axial group. This is the equatorial. So the way to differentiate axial and equatorial, axial's exactly straight. Are we good? Okay, I'll draw all, since is that answer your question? This is the more stable because the large is in equatorial.
I almost don't understand the answer key here. It has this one.
Okay, let me.
I don't understand which one it's showing.
Oh, okay, I see. Let me take a look. Oh, do I have?
Is it that one?
Mm. Oh, okay. Okay, let me explain that to you. Okay. But are you good with we're large and small with this? Okay. I will draw the axial after I explain to her. Okay. Now, okay. There one more step for compound D. Which, just in case, this is something I would say not required for your midterm, but this is, yeah, it's a little bit, let's say, who is actually smaller? It's about steric hindrance, okay? So this is a CH3. I only write the large group based on just like there's a huge chunk of that. Okay. So in reality, okay, because it's double bond, it's skinnier than CH3. So this one, that's something else, right? So this one actually occupies less space than a methyl group. So this is actually, so I know I labeled this one with crewing as large in the first. There is something called, you don't need to know this for now. It's called A13 string. There's a table of this. For each substituent, there is a certain number. You don't need to know for 118A. Okay, if you go to take 331, that's you will need to know this number. Okay, it's something else later. This one and this one, they have different number. What we think, okay, in your case, it's like a huge bulky thing, because of the double bond. They actually have less 813 strain. So yeah, it's if I will ask something like this, I will give you the table of the strain, so you know who is actually larger, who is smaller. Are we good? But for your case now, you are very likely just compare with hydrogen with CH3. Of course, hydrogen is going to be smaller. Yeah. Yes.
Is there like a relationship between equatorial, axial, and like wedge and dash positions? Like is
Yes. Okay, if you draw the 6-member ring, this one, the large group, okay, now should be dash, use large, okay. The dark blue one is pointing up, so it should be small. Okay, they're the same.
so then is the equatorial the dashed one or the wedge one?
It's depend on is that pointing up or pointing down. Equatorial can be pointing up, can pointing down. If it's pointing down, it's dash. If it's pointing up, it's wedge.
Okay, thank you.
Okay, are we good? Are we good with chair? Are we good? Yes.
I have a small question. So if it's like we always put like the largest substituent as large, but then if it was like something like 3 methyls versus like an ethyl, then like would we still put?
Okay, if you will be given a question like that, I'll put a table of like you depend on which strain
Okay.
has. Okay, hydrogen of course have the smallest strain. I'll list I'll give you a clear clue on.
But then like wouldn't like the combined strain between the smaller molecules be larger than the?
It's more like okay. If you are really going to have one like that, it's going to be hydrogen, and then we'll show you. Okay, this one. We'll show you this one. It's already been combined. Okay, or it will be this one. Okay, it's already been combined for you. It will be because just like you said, it's not simply one methyl will be higher. A lot of going on. Okay, yeah.
When you have a 6-member ring, how do you tell which substituents will be axial and which one will be equatorial?
Okay, let's actually put that in the third part because I think it's already 12 minutes for this.